Inductive and deductive reasoning. So, looking at these definitions, the thing to remember is inductive reasoning uses patterns, while deductive reasoning uses facts, definitions, accepted properties, and laws of logic. And then also with inductive reasoning, if you can find a counterexample, then it proves it false. So let's look at some of these over here. Each time your mom goes to the store, she buys milk. So the next time your mom goes to the store, she'll buy milk. So this indicates a pattern. Every time she goes to the store, she buys milk. But let's see if we can come up with a counterexample. Hey, on Wednesday, she went to the store and didn't get milk. So this one is inductive reasoning. It's based on patterns. Rational numbers can be written as fractions. Irrational numbers cannot be written as fractions. So half is a rational number. Okay. That's a fact. This is a fact. This is a fact. This is the conclusion. This is deductive reasoning. It uses facts. All men are mortal. That's a fact. Mozart's a man. That's a fact. So this conclusion at the end, Mozart is immortal, is a conclusion based on facts. Can we prove a counterexample for that? All men are mortal. Superman's immortal. Superman is not a man. Superman's an alien. So, yeah. That one is deductive. Each time you clean your room, you're allowed to go out with your friends. So next time you clean your room, you will be allowed to go out with your friends. So it looks like it's a pattern. It's probably inductive. Can you prove it wrong? Maybe you clean your room and then you crashed the car last time you went out. So there's a counterexample. You weren't allowed to go out after that. So that one is inductive reasoning. So basically we're looking at facts versus patterns. Okay, syllogisms. So basically when you have a series of statements that link together, so for example, P links to Q, we use Q again to say R. So red links to blue, blue links to green. So if those are linked together, then red is also going to link to green. So what does that look like when you're actually doing it? Here we go. So if it does not rain, then I will walk to school. Here's another one about walking to school. If I walk to school, then I will wear my walking shoes. So you take the red one. If it does not rain, then I will wear my walking shoes. There you go, there's that one. Same thing here. If x is greater than 1, then 3x is greater than 3. If 3x is greater than 3, so the blue ones match up again, then 3x squared is greater than 9. So to write this one out, if the red one, if x is greater than 1, then the green one, 3x, the quantity squared, is greater than 9. Okay, you can't have longer versions of these. So let's think here. If Johnny doesn't have groceries, then he gets hungry. So Johnny not having groceries is the first one. So then being hungry links to being irritable. being irritable links to saying a mean thing to his cat. Saying a mean thing to his cat links to the cat plotting revenge. The cat plotting revenge leads to Johnny being framed for a crime. Johnny being framed for a crime links to him going to jail. So the very last thing is him going to jail. So if all these things in the middle are true, then you can say this statement: if Johnny doesn't have groceries, then the conclusion, then he goes to jail. Yep, so that's everything.